So
I don't remember if we went back and did it with the others or not.
So the reason the assignment is super simple, because you're going to sort and shuffle an array list, and array lists use generics. And so we want to sort and shuffle some generic lists of things. So simple assignments, but new concepts that we haven't really used with a thorough explanation of in the past. But what is a generic? Well, I have here on the title that allows us to have fewer overloaded methods. If you think about an overloaded method is a method that has the same name as another method, right? It does the same thing, but it has a different header. So instead of returning a string, it returns an int, or it expects a string as a parameter instead of expecting an int as a parameter. So one area where we might use something like that, an overloaded method, say we wanted to search for an employee. That's one that I always pull out of my head. I don't know why. But I want to search for an employee. My search screen allows people to type in the employee ID, and it also allows people to type in like the last name. And I want to just call search and pass whatever they typed in. Well, if my employee class has an overloaded method called search, and in one case that method accepts a number, then the code for that method is going to search by employee number, right? If my other method, search, expects a string parameter, in that method I can search using that name value, that string. So my search method to the other calling applications looks exactly the same. They don't have to worry about which search they're doing. They just have to pass the data that they want to be used in that search. And our overloaded method in our application takes care of that and calls the right method. Well, I could actually implement that method using a generic and only have to have it once. And then in my header of my method, I could say, this method expects a generic data type as a parameter. So let's see how to do that. We can get away from some of that overloading. First of all, whenever we're working with Java, our syntax errors are always detected by the compiler, right? And so that makes life great for us. We may not realize it, but it makes our lives great because we don't get to compile code that has errors in it. Because if we compiled code that had errors in it, like a variable name that was unknown, we might use that code for years and never have a problem. And then it finally executes a path that tries to run that one line of code that uses that undefined variable, and it crashes, and it costs our company all sorts of money, and we can't find the problem because it's been running forever. Surely that problem couldn't have existed. Well, we get away from those kind of problems by having the compiler do syntax checking for us. These things can't get through. Well, some things can get through, because if I used the keyword object in Java all the time, and I said, this is an object, and this is an object, and this is an object, that would be true, right? Because every object I create in Java inherits from that base system object. So if I had a list view, I could call it object. If I had an image view, I could call it object, because they all inherit from that original object. Well, that means I could cause myself some errors, some runtime errors, because I could refer to two things that are not consistent, both as objects, and cause problems. Maybe things aren't exactly the same. So generics are really only exist for the compiler, so that the compiler can help us find problems like that are object related. We've said we're going to use this type of object. It's going to make sure we really do use that type of object. So here's a generic. The letter T inside the greater than, less than brackets. And this is a formal generic type. So when I see something like this in my code, that is a type description. I'm saying I use a generic here in this code. Now, that thing is only for the compiler. It's like a variable for the compiler. That's all it is. So it lets you make a parameter out of the data type that you're using. So instead of saying int, I can put the uppercase T within the greater than and less than symbol, and that says, I'm going to use some data type. You don't know what it is yet, but I'm going to let you figure it out, and then I'm going to use that data type. So I can be more flexible, and I don't have to worry about saying, this always use an int. Well, sometimes it uses an int, sometimes it uses a string, sometimes it uses a double. I want to make that more of a parameter. So now I can parameterize the data type instead of having to have that coded in all of my code for the compiler. So besides just declaring a method with a generic data type, I could use a class and say that this class accepts a generic data type. And that's what they did with the list class. They said, this list is going to be made of strings, or this list is going to be made of image view type data. And then they're specifying what generic type they're going to be using there. Now, whenever we create our generic, we have this formal generic type that we put in our code, and then the angle brackets are what are telling the compiler that it's a generic. Notice that it hasn't always been available. Just since the JDK 1.5, which is almost always available, but you could probably find some really old code that didn't know about generics. So how does it work? Well, we place that formal generic identifier in our code. Now, this doesn't have to be the letter T or the letter E inside the angle brackets. It could be any letter that you wanted. It could actually be like anything you wanted. It's just that as things have evolved, people pretty much use the uppercase T and the uppercase E to indicate that it's a generic. So it's just kind of a convention. You don't have to, but that's pretty much what everybody uses.
So could you like use a full string there?
You could if you wanted to. So you could say generic indicator in there and in that. And that would be really descriptive too. But it's just as time has evolved down to the smallest level. And so a lot of times people use the letter T to indicate type. It's just the data type that's going to be displayed there. And I don't know about the E. I can't think of any reason for that. I guess extended type or something like that. Now, we are not going to leave this generic in the code though. When our code gets compiled, that generic indicator is going to be removed. The compiler is going to determine from all of your code what that generic data type should actually be for this method, for this class, for whatever, and replace that generic indicator with that data type. And whenever that replacement happens, that's called generic instantiation. The compiler is saying, oh, I see, you're going to use this as an int. So I'm going to put int everywhere instead of that generic indicator. Now, when that instantiation occurs, the generic can only be replaced by a reference type, meaning an object. Yes, sir?
Are you able to have both types?
Do what now?
You're able to have multiple types in the list.
You'll have to try it and see what you can do. So I'm not really sure. You can only have one generic listed in a, when you create the array list, really where you have multiple types anyway, isn't that? I'm not sure what you
Then it would treat them as string.
the string for everything.
I
I have
think
to
it'd be
mess with
like-
it. Because you can get pretty flexible. I'm not exactly sure how flexible you can get.
I think array still has to be the same type. I think array list
Array
has to be different
list.
types.
Could be different things. That's what I'm thinking. So what does this mean that I can't replace a generic with a primitive? It's got some info there. I can't make it int. I could make it uppercase integer. So what's the difference? Well, remember within Java, the primitive data types, int, double, char, decimal, there's just a few others. The ones that start with lowercase letters, these are our primitives. We can't use a primitive data type as a generic. So we can use the object data types like integer, double with the uppercase D, char with the uppercase C. So these are our primitive data types that have been wrapped up as an object. We can use those. So if we use a primitive type, the compiler is going to automatically replace it with the object type. It's going to do that conversion from a primitive to that wrapper class. So what do we care about these generic classes and interfaces for? Here's one. Let's see if we'll look at this thing real quick. Here we have a stack. Now this stack is a data representation here. We're saying that a stack is just a way that we could organize data. We'll be looking at that in the next week or two, with different types of data organization methods. But the stack is a type of data organization that says we're going to keep adding things to this stack, but then when we take things off, it's going to be the thing on top. So it's going to be last in, first out. Don't look at this in that PowerPoint, it's backwards. It should say last in, first out, because it's a LIFO. So a stack of plates is a good example. We would use a stack within the operating system. So think about it for our programs. When our programs are running, I have my program that begins with the main. When my main starts running, it calls a subprogram sub1. It calls a program sub2, calls a subprogram sub3. As these calls are made, they're placed in a stack on the operating system level, right? Then when sub3 gets done executing and it issues its return, it's going to be removed from the stack, last in, first out, and that'll return control back to sub2. When sub2 gets complete, done executing and issues its return, it'll be removed from the stack, returning control to sub1. When it gets done, it'll be removed, returning control to our main. So you can see that the operating system uses a stack type mentality when it's keeping track of what method is in control of the processor. So let's look at a stack. Let's see if we can find this one. I have that it's in 11.10, but I might need to update. So let's go see if we can find this implementation in Ravel. See if I can get logged in. So it's chapter 19, but other than that, everything's the same. So I'm looking at section 19.3, defining generic classes and interfaces. The stack class is something that exists in Java at the system level. It's also something that we might create on our own in a program. But in this example, they give us the ability to create a generic stack class ourselves so that we can use a generic. So let's create this one. I'm going to start up Netbeans. Maybe. Yesterday when I started it up, it took a really long time. I don't know if they pushed some sort of update down over spring break, but I hope it doesn't take that long for everybody. Popped right up this time, but boy, yesterday it was pretty slow. While that's loading, a couple of things. If you haven't been watching the upcoming events on the Slack channel, don't forget on Fridays, Kirsten's doing the Raspberry Pi Club, Lab, whatever you call it, experimenting with things on Friday afternoons across the hall, I think at 1. We'll go over there if you want to explore with Raspberry Pis. The other thing is a week from tonight, the E-Factory, Dr. Ford is giving a presentation on adding Alexa skills using C#. besides the fact that it's just an awesome topic that I'm sure you'd be very interested in, it never hurts to say hi to Dr. Ford outside of school, right? And say, remember who I am whenever I need you to change my schedule or override something or remember Dr. Ford's the one in charge. So it's always a good idea to have her know you on a good way. So that's next Tuesday at 6 o'clock at the E-Factory thing. And it's on Slack in our upcoming events. So don't forget to watch those. All right, so I have a whole bunch of stuff that I haven't checked into GitHub. I'm glad you guys are doing better than that, but I'm just gonna go ahead and create another one. I want a new project. Still a little weirdly slow. Now for my new project, this is gonna be my generic stack. I'm gonna name my project listing 19_1. And I want to create a main class, but I don't want it to be named this. I'm going to name it generic stack. So in our stack, we want to do things in the same way. So let's put some comments up here. We haven't put any in for a while. This is the generic stack. I'm getting it from them. And so we're going to build a stat class that uses generics. So in Java, I could probably find a stat class somewhere that already exists that I could use, but I want to create my own because I've decided I want to be able to build a stack of strings or build a stack of integers or build a stack of the tiles that I just created for my game or whatever it is that I need to build a stack of. So I could use my generic specification for any of those things. So the first thing that I have to do is at my class level, I must update my class statement. Now this is just if I want the class itself to be willing to accept a generic specification. And what I'm going to do is put that generic specifier right after the class name. And I'm going to use the uppercase E for this one. So I'm basically saying our generic stack here uses some sort of generic entity. Now we do have a class level variable for this. We're going to use the array list. And we're going to say this array list is going to be whatever data type our generic specifier is. Okay, so let's put a comment in there for that thing. So first of all, we're using the full path to the ArrayList class, right? We didn't include an import for that java.util. We just typed it in. So kind of like using a command prompt, we can use that full path. Now, whenever we created the generic specification, we're using the same generic specification. So we're going to add the generic specification to the class. Now, notice how we've added it. We've added it, first of all, in our data type, right? The data type for this list is going to be an array list with a generic type. But then we also had to add it to the constructor. So when we call our constructor for our array list, we're saying again, with a generic type. So notice how that looks kind of weird. You guys got used to it with your action events in our last few chapters, but we end up with the open and closing parenthesis after that generic type specifier when we're using it in our constructor. So we have to add it to the class data type and the constructor. So it's in there twice. It looks duplicated, but it's not. So since we put, does that work? Oh, it does. Look, it's really hugely green. I could probably blind somebody. Since we put the E, where'd you go? Oh, there it is. Since we put the E up here in our class statement, it matches. So all of these places within this class that I do, the braces with the uppercase E are going to be replaced with whatever data type we end up using for this class. So they will all become the same. Now we're going to create some more instances here, some more entities in our class so that we can see how to use this generic in different types of things. So here's our generic stack. We've got our variable here that we've created that's going to be a class level variable that also is using our generic data type. Now let's create some methods. First of all, we're going to have a method that uses an integer or returns an integer, sorry, called getSize. Now in our getSize method, we're going to use the array list that we're creating here in our class to just use the size parameter. And whenever we're looking at our array list, we can type list dot, which is the name of our array list, and then IntelliSense will help us with a whole list of all of the methods and properties that are available to that array list class object. So we're sort of mixing up a few things here. But in my array list class, I see I could do a sort, I could do a splitterator. I don't know what that is, but I bet it's cool. I could switch it to an array, because sometimes we want an array list to become an array. So all of those different methods and properties are available. The size property is just going to tell us how many entries are in that array list. So we're going to use that to return to our caller when they want to know the size. Because they're just working with this stack. They don't know what we have behind the scenes there. Now when we're working with a stack, there's a special command called peek. And peek says, you can look and see what the next thing in the stack is, but I won't take it off the stack. I'll let you peek and see what it is. Is it a dirty plate? Is it a clean plate? We can take a peek at it. So for that peek, we're going to return list.get the last thing that was entered on the stack. So we want to get the size of the stack and then subtract 1 from it so that we can get that very last thing. So we're doing some great things in this class. We're going to be using the array list class to create our own stack. Now, another thing that we want to be able to do with a stack is push When we push, we're adding a new thing to the stack. Well, what kind of new thing are we going to be adding? Whatever data type our generic is, that's what we're going to be adding. We're going to call this object O within our push method. So in our push method, then, we can say that we want to add this object O to our list. Let's put a comment above that one. Bless you. So in this method, our push method, we're using our generic E as our parameters data type. In the peak method right above, we're using the generic data type as our return type. So any place we have that uppercase E, we're actually replacing that. The compiler will for us when that instantiation occurs. Okay, a couple more methods. We need a method called pop. The pop method is actually going to look at the item and tell the user what the item was that was on the stack, but it's going to remove it from the stack. So it's like, you want to know if that plate is clean or dirty? Well, here it is, it's dirty and it's yours because it's not on the stack anymore. So that's a pop. Now, when we pop something off the stack, we're going to return that item to the caller. So that's why our generic is a return value in this method. Now, we could actually use our generic in our lines of code. So we say E, meaning our generic data type. This E data type is defining an object named O, and we want to set that equal to the last item in our list. Now we want to get rid of that item. So our pop is a little bit more than a peak. We have to actually remove it. And then we can finally return it. Two more. We want a method to allow our users to query to see if the stack is empty. We'll call it isEmpty, and it will return a Boolean value. We're going to use the Arraylist class again. And looking at the Arraylist class, there is an isEmpty method, and that's the one we're going to use. And finally, one more, we need to override our toString. In our toString, we're going to return this nice message, our stack, and the list dot toString. So we're going to call that Arraylist class and use its toString method to print out all the entries in the array. Now they have a few tester items available, so let's try one. First of all, in our main, I'm just going to leave it in the same, and I need to put it in its own class. Let's see. What do you want to do? We'll try it in its own, in the same class and see if it gets all mad. So I want to create an instance of a stack. Here's our generic stack. Now, whenever we use our generic stack class, let's see what kind of error it's saying. Oh, it's just bad because I'm not done. I have to include that generic parameter of what data type we're going to use. So for this one, we want it to be a stack of strings. We're going to name it stack1, and it's going to be a new instance of our generic stack class that we just created. So when we instantiate our class with our generic class, we have to specify the data type in the first specification of it, I guess, in the data type section. But then for our constructor, we don't have to. For our constructor area, we can leave the greater than, less than empty, because it's just going to use whatever data type we specified in our data type parameter. So right here, when I run this line of code, our generic stack is going to have that generic resolved. The compiler is going to say, oh, I see, this generic stack should be a string. So it's going to replace within generic stack, every place we have that uppercase E, it's going to be replaced with that string data type. Let's put some things in our stack. We'll push London. Remember, we created those push methods. Paris. Berlin. And let's print that stack. So I want to print stack1. Will it work? Took it a second, but it finally did. So I get output that my stack has London, Paris, and Berlin in it. So that's fine. We could try some of our other methods if we wanted to. Stack1 dot pop. And then we could print it again. Now we get rid of that last one. So notice with our pop, we're not passing any parameter because it's always going to get rid of the last one that was pushed onto the stack. So that's great. It's all well and good, but what does it matter? I mean, here we went to all this trouble to create this generic class with these E's, and we could have just put the word string there, right? Because it's not really saving us anything. The savings comes when we create another stack. So let's create another one, a generic stack. And this time, we're going to say that it's going to be a stack of integers. We'll call it stack2. We'll call it, say it's our generic stack constructor. Now for stack2, we've got the same exact code running. We didn't have to create anything new. We can push some integers. Now they're going to make a note here that we'll be auto boxing 1 to be a new integer object for this to happen. I'll put a 3 on there, and then I'll print it out. Does it run? Yay. So we can use the same exact code now, whether we're using strings or integers. And let's see, let's try with our regular array list. So let's create an array list. I don't have that import. Now with our array list, we can add things. And it says you can add objects. So I want to add a 1. And I want to add a string like and then I'll print it. So if you look and you mess with the array list, you'll see our array list lets us mix data types in the list. So our generic stack is taking advantage of that capability using an array list behind the scenes, but it's limiting us to one data type because a stack is theoretically usually just one data type, like a stack of integers or a stack of plates, right? We can't have a stack of many different things that tends to topple over. So we're creating our stack implementation on top of the array list because we know the array list is going to support whatever data type we want to use for our stack. Does that make sense? It's kind of like taking something like the array list and limiting it a little bit. This example does. But what the example is trying to show you is all these different ways you can code to include a generic. So we see here, we could have a generic included in our class. We could have a generic included in a variable declaration. We could have a generic included in our return value, our parameter value, even within our code itself. So we can do all of those different things with generics. So sometimes when we're looking at an example, it's not as obvious how we could utilize that on down the road as it could be because it gets too complex, because we're a pretty complex area here. But if I wanted to use this generic, I could use it for anything that I needed to based on my business. So I always like to think about my friend that worked at Conoco that wrote all of that. I've probably told you guys about it, wrote all this code for how much a tank can hold because there were billions of measurements and things because a storage tank for oil settles. And so some of the walls bow and some of them are straight and it sinks a little bit. So some of the walls might be a little taller than other walls. And it has a big giant like lid on it that settles down with the oil so that no air can be touching the oil. So there's a lot of really complicated calculations of figuring out what the volume is within that tank. So if I have a volume calculation like this, it would be great if I could call it for oil storage tanks, if I could call it for jet fuel storage tanks, if I could call it for just plain old gasoline storage tanks. And if that volume comparison worked the same, then I wouldn't have to recreate that code for those different storage mechanisms. I could just use that same method over and over for those different types of data.
You know, kind of like gallons, liters, milliliters.
Mm-hmm. Yeah, because you don't want to have to reinvent it for every single thing, like to be able to use that as a generic. But so it gives you a lot of capability. It's fantastic. All right, we don't have a huge amount of time. Any questions about that right now? We'll look a little bit more at some more generic stuff next time. Yes, sir?
So if you create that list inside your class, and then you create like this new generic stack, does that stack still have like all the functions like shuffle and will it allow you to alter the data of that class?
Oh, that's a good question. Let's see. So could we do that? Could we say stack one dot shuffle?
And shuffle and put the name in the parentheses.
Do what?
It's just shuffle and then parentheses.
Put the stack one in there. Will it let us do it that way? Shouldn't, right? Because we're in our main. So now if we went inside our stat class though, where that array list does actually exist, then we should be able to. So let's see if I should be able to just put it someplace. List dot shuffle or shuffle list. I'll do it that way. Don't I want array list util or something?
Probably, yeah, probably just import.
That's what you get for not using the import. Can't do it. Java.util. I can't do it. It's too late.
No, you can't do array list there because that's generic.
I just did collections and did the import.
It did it for you.
Under collections and then I had the import and it worked. So,
So you can do it in your generic stack or in your main.
oh, you know what? Since I added the collections, I did it under the public EPUB. And just made that collections. So let's.
So anyways, to answer your question, in your generic stack, because you're using an array list, you could use any of the array list functions. In your main, where you create an instance of a generic stack, you can't, because generic stack doesn't inherit from array list. If it inherited from it, instead of just creating one, then you would be able to do that you're thinking of.
So even though your stack is technically an array list, since it's private,
Right.
it doesn't actually know it's an array list.
No, nothing outside of it would know that it's an array list.
Okay.
Right. So if it created that array list because generic stack inherited from the array list class, then outside classes would be able to utilize those features too, the way you're thinking. So that's the difference, is just that it doesn't inherit from that. So I just can't do imports right now today. It's too hard. Okay, so not too much time. Wanted to give you guys a little bit of time to get that unit exam done and take a look at anything else that's outstanding. The 2 assignments that we have, you guys will probably almost be able to get done in this amount of time. So if you get them done, do come back on Thursday. Talk about other generic things. So, but I won't bother you anymore.
Will they be announcing the eFactory stuff on the Slack channel?
Yeah, she has already, if you're on it.
Okay.
Do you see it?
Yeah.